and welcome to my YouTube channel, Spino Science. Today I will be teaching you all on what exactly the Bohr model or diagram is and how to effectively use it. So first of all, you might be asking, what exactly is a Bohr diagram? Well, this huge thing that you see in the center, that is what a Bohr diagram is. It essentially looks like a large circle with many small circles inside it, or an omelet, and it is used to represent an atom. Now that you know what exactly it looks like, you might be wondering, how does it relate to an atom? How does it show what an atom is? Well, the smallest circle that you see inside, that is the nucleus. That is where all your protons and neutrons go. Meanwhile, all these other circles that you see on the edges, these are the orbitals which house the electrons. So that is a Bohr diagram and its relationship to the actual atom. Now you might be wondering, how exactly do you use this Bohr diagram? Well, I have a perfect example for that. I have prepared let's say an atom of oxygen. Just by looking at the periodic table, we can tell that oxygen has an atomic number of 8 and an atomic mass of 16. From the atomic number, you can immediately find out the number of protons and electrons that you have. For example, this oxygen has an atomic number of 8. Therefore, it will have 8 protons and 8 electrons. So the first step that you want to do is, now that you know that you have 8 protons, you want to go inside the nucleus, or the smallest circle, and write an 8, a lowercase p, and a positive. This tells you that you have 8 positively charged protons in your nucleus. But you might be wondering, we don't only have protons, we also have neutrons in our nucleus. Well, if you look at the periodic table of elements, you might not immediately be able to find the neutron. But there is a formula that you can use. To find a neutron, you need to subtract the mass of your element by the atomic number. So in this case for oxygen, our mass is 16 and our atomic number is 8. So you do 16 minus 8, which should give you 8 neutrons. So your next step would be to, right beneath the positive, write a p, a lowercase n, and no plus or minus because it's a neutral subatomic particle. Now you have officially completed the nucleus, but we still have the electrons to go. So you might be wondering, where do the electrons go? Well, they go on these orbitals, everything except for the nucleus. So this right here is your first orbital, this is your second orbital, and this is your third orbital. Each orbital can hold a certain amount of max number of electrons. For example, the first orbital can hold a maximum amount of 2 electrons. The second one can hold a maximum amount of 8 electrons. The third one can hold a maximum amount of 8 electrons. And the fourth one, which is one that we will not be dealing with today, can hold an amount of 32 electrons. So, now that we know the amount of electrons these orbitals can hold, we now have to place the electrons onto the orbitals. So we know that we have 8 electrons, and we know that our first orbital can hold 2. We would go like this. You would put our first electron somewhere on the diagram, and then put our second electron just directly opposite of it. This is working. This is how you should draw your first orbital. You should not go like this or this. The reason is because these electrons need to be placed evenly between each other. They need to be placed opposite of each other. Otherwise, this diagram is not correct. So you want to place them opposite of each other like I did first. Now that we've completed our first orbital, we have 6 electrons left that we need to put on here. We know that the second orbital holds 8, so you want to evenly divide 6 electrons on the second orbital. Let's give my best here. 1, 2, 3, 4, 5, 6. This is pretty close. You can move some electrons around here and there, but this is how your oxygen element should be looking on a Bohr diagram or model. It has fulfilled our needs for the nucleus and the orbitals, and it goes by the amount of electrons each orbital can hold. We fulfilled that. The first one can hold second, and we got to 6 on the second orbital. So we are done with our oxygen example. Now we will be trying an example of lithium. So to start off, we know that lithium's atomic number is 3, and its mass is 6.94. So as we learned, now that we know our atomic number is 3, we know that we have 3 protons and 3 electrons. So let's go ahead and draw that. 3 protons, and we'll wait for the electrons later. Now our mass is 6.94, but we can round that to the nearest whole number, which is 7. So to find a neutron, we need to do the mass minus the atomic number. So 7 minus 3 is equal to 4 neutrons. So right here, we put 4 neutrons, and our nucleus is done. Now that we know that we have 3 electrons, let's look back at our rules. The first orbital needs to hold 2. So let's put 2 of our 3 electrons right here. 1 and 2. And now that we have 1 electron left, we can put that anywhere on the second orbital. It would not matter. So I'll just put it there. Boom. That's our example of lithium. You have done the Bohr model for lithium. Now let's move on to our final example, chlorine. Chlorine is a big element, so this will require a lot of space, which means extra practice. So our atomic number is 17. So therefore we already know that we have 17 protons and 17 electrons. So let's just draw the amount of protons we have. And now we know that our mass is 35.45, which we can round to the nearest whole number, which would be 35. And then we can do the mass minus the atomic number, which would be 35 minus 17. 35 minus 17 is equal to 18. So now we know that we have 18 neutrons. Now that we have figured out the amount of neutrons that we have, we need to figure out our electrons. So the atomic number is 17, so therefore we have 17 electrons. Time to place them on the orbitals. So we know the first one can hold 2, so let's put 2. And now we have 15 electrons left. The second orbital can hold 8, so let's do 15 minus 8, which would be 14, 13, 12, 10, 9, 8, 7, 6. We have completed our second orbital and have made it to maximum capacity, and we have 6 electrons left. As far as I'm certain, let me just recount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, 7 electrons left. Sorry about that. So our third orbital can hold 8 electrons. So let's just add the remaining 7 on here and try to balance them equally. 1, 2, 3, 4, 5, 6. We'll put 7 right here. So that is your Bohr model for chlorine. This was a tricky one and it required a lot of space, but that is essentially how you do it. Thank you for watching this YouTube video, and I hope that you learned how to make a Bohr model and diagram successfully. Maybe next video or in a couple of videos, I will teach you how to do the Bohr diagram after the octet rule, which is very advanced. So I hope to see you then. I hope you learned something new, and peace out.